Hi, this is section 3.4, Discrete Math. We want to look at the Leslie matrix, and this will be part one. And so right now what we're doing is setting up the concept of the Leslie matrix, so it's going to be kind of cumbersome right away. Then in the next section, 3.5, we'll show you how to use matrices to make this a lot easier. So what I'm going to do is, first of all, I need to explain this chart and what's going on with it, and then I'm going to set up the spreadsheet for this. You can choose to set up the spreadsheet, but I think it's really good that you see what happens on there. But I also will show you the calculations that you can do by hand to get this information. Okay, so what happens now is that we have an animal population which has characteristics as described below. So what does this mean? Well, first of all, this would be an age category. 0 to 3 months, 0 to 3 years old. This one would be 3 to 6, 6 to 9, and so on. So that would be the age of that animal. So what happens is that we're going to show what happens subsequently. So for instance, after this animal passes 3 years, then all of a sudden they're going to pass into this category here. And once animals in this group pass 6 years, they're going to go into this group here, and so on. And so that's, first of all, a concept that you have to understand, is that all of these animals will move on to the next age group eventually. The next one, I'm going to skip over birth rate right now. We'll talk about the survival rate. What happens is that this survival rate means how many of these people or these animals in this age group will pass on to the next age group. So right now, say for instance, I have 10 people in this age group. 60% of them will live to get into this age group. So only 6 will pass on to the next age group. 4 of them died. So in other words, if I talk about this initial population, 15 of them, only 60% of this 15 will pass on to the next age group. And then similarly here, 90%. So this talks about infant mortality and things like that. Anything that was born, they're more likely to die when they're young than as they get older. And so 90% move on, 90% from this group move on to the next group, 80%, and then as they get older, they'll die off. And then here, 15 to 18 years old, this means that nothing lives past 18 years old. There is no survival rate past that. So now what does this birth rate thing mean? Well, this will be how many newborns are born from each set of parents, and usually this represents females of a group. How many babies are born relative to the number of adults in each age group? Well, this makes sense. If they're very young, they don't have babies, so the birth rate would be 0. Now, if I look at this age group, 30%, and so if I have 9 right here, 30% of those will provide an offspring. So what happens is that about 30%, about 3, give or take a little bit, of these 9 animals that we have here will produce an offspring. Those offspring will go back into this 0 to 3 category. Similarly, the adults in this category, 80% of them will have an offspring that will also go into this category right here. Anybody new is going to be in this first category. And then 70% and 40%, so on, are all the babies are going to go into this one right here, initial population. So once we span a 3-month period or a 3-year period, this 15 moves on, and now we need new babies. Where do those babies come from? Well, they come from this birth rate of each one of these groups, and they all go right in here. Okay, so let's see what happens to the population over the course of time. So to calculate the new rats that will be born, all we do is take the birth rate times this, and add them all up. So like I said, if you want to do a spreadsheet, get the spreadsheet open and we can do this. Copy this information in. So what we do is, after one cycle, which means a 3-month period, because these are going to be months, what we're going to do is we want to find the new babies. The new babies are going to be found by taking the birth rate of the category and multiplying it by the initial population. And then we're going to take the birth rate of this one and multiply it by the population in that category, and then so on. So here's what I did. I just took 0 times 15 plus 0.3 times 9, 0.8 times 13, 0.7 times 5, so on, so on. That's all this is. And so the new bursts, or the new babies that I'm going to get after one cycle, will be 16.6. So that's the new babies that I'm going to have. So that would answer your first question there. If you want to write out the numbers, here we go. You can pause that and get that down. Then the next category is calculate the number of rats that will survive in each age group and move up to the next age. So that means that if I have 15 here, how many of those survive? Well, it's 15 times 0.6. So my next number that I'll have right here is just the 15 times the 0.6. In the spreadsheet, I can just represent it by multiplying these two together. So if I get those together, I get 9. Then I can take this 9 and multiply it by the survival rate. So I'm going to take this one right here and multiply it by this survival rate there. And I can continue to do this. So I'm going to take this 13 and multiply it by that survival rate in that category. And these are the numbers that you're going to get. You can do this by hand as well, but I like the spreadsheet for it too. And then now you're going to be multiplying by 0 all the time, so then you're just going to end up with 0. Okay, so that's the numbers that you would get. Here's my scribbly calculations if you want to see this. 15 times 0.6 would give me 9. That's what I put right there. This in red right here would be my subsequent cycle 1, after one cycle. And then the distribution of rats in each age group would just be this right here. This would be the distribution. In each age category, how many rats do I have? You also can look at the spreadsheet. This would be the distribution after one cycle. Then the fourth one says, how many total rats do I have? Well, you just take this red number, red number, red number, red number, all these red numbers and add them up. When you do that, you get 49.4. That's the sum of the rats in the distribution. Now you might say, well, I need to round this because I can't have a 0.4 of a rat. Well, that's true. However, if you keep on rounding, that will ruin the model. And so we need those pieces to project out what happens over the course of not just 3 months, but 6 months, 12 months, 4 years, etc. Okay, then predict what the population will be after 2 cycles. So let's go to the spreadsheet and do it that way. So once again, I need to find the babies. So I'm going to take this new number. I ignore all these numbers now. They're gone in my mind. I'm taking these new numbers and using all of these. So I'm going to take 16.6 and multiply by 0. That would give me my number of babies here. So here we go. So I'm going to take this number and multiply it by 0. Obviously, that's going to be 0. Then I'm going to add this number times this one here, and so on. So I've multiplied all those. This is going to give me all my new babies because that's the birth rate in each one of these categories. So I've done that all there. What do I get? I get 18.97. So this is the most cumbersome calculation. These other ones are pretty easy. All you're going to do is take this 16.6 and see how many move on here. Well, it tells you the survival rate is 0.6. So all you do is you go 16.6 and I'm going to multiply by the 0.6. That's my formula that I'm going to get. And in fact, if you know your spreadsheets, this should fill across when I do this. Let's see if that worked or not. So this one says 8.1. Where does that come from? C6 times C3. Well, C6 is right here, times C3. Yep, that worked. And if I check just one more, this should be D6 times D3. Yep, yep. And so then I should be okay with that. Okay, so this would be your distribution after 2 cycles. And if you want to see the calculations here, these are the calculations. These are for all the babies. So I get 18.97. That gives me this value here. And then here are the other values multiplied out. I didn't write all of them, but that's what we have. Then you can total them up as well to see how many total babies you do have. Okay? So this is the beginning of Leslie matrix. This is kind of the cumbersome part. to try to show you where all these numbers come from, because I think you need a good understanding of this first. And then after that, we'll go to the matrices, and the matrices will be a little bit easier to use. Thanks very much. Have a great day.